Alright, want to do a video on Earth's climate change and shit. First, we talk about Mercury. Mercury, as you may know, is the closest planet to the Sun, and shouldn't be too surprising that it's really fucking hot. Like, really hot. What's interesting though is that it's only during the day. During the night, it's like 80 Kelvin, which is minus 10 Celsius, minus no, that's minus 190 Celsius. Yeah, never mind. 190 Celsius, something like 300 Fahrenheit. I don't know, but there's a huge fucking variance. Let's see. Bit of a give me a thing here for atmosphere. It's just like during the day, it's very fucking hot. Yeah, here, atmosphere. And during the night, it's really, really fucking cold. And it has the greatest variance in like day-night temperatures of any planet. And the reason basically is that during the day, it's pretty close to the sun, and it gets a lot of heat from the sun. And during the night, there's very little sunlight, well, none, because it's facing away. But also that there's no atmosphere that retains the heat. You look at the combined pressure, we're about 10 to the negative 14 bar, 1 nanopascal, which is almost negligible. Its atmosphere is basically, is it similar to the moon? Or it's like, but you could just doing like a math about like the rate at which shit falls or just stuff like that. You could almost kind of just negligible for air friction. Anyway, next up, Venus. Now, what's really, really interesting is that Venus is like twice as far away from the sun as Mercury. So it, due to like the square, like r squared, radius squared, it has a 1/4 of the heat basically of the sun's light hits it, but it's actually hotter than Mercury. And that's true in the day, like day as well, not just the night, which is kind of cool. And the reason for that is that its atmosphere is very different. Not only does it retain a lot of the heat, it retains a shit ton of it. And so much that the temperature during the night is apparently isothermal with the day. Like there's no temperature variance during day or night, which is weird. But yeah, surface temperature 467 Celsius, 872 Fahrenheit. Like, holy shit, that is hot. And it's yeah, really, really high pressure. Like, Venus's atmosphere is way, 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 way more dense than Earth's. It's like the where Mercury is the extreme of very little atmosphere. Venus would be the extreme of a fuck ton of it. It's 96% carbon dioxide, and yeah. What's interesting though is that as you like, yeah, as the height in kilometers from the surface, since it's like the surface temperature is like uniform around Venus apparently. The it's also true that like the distance from the surface is roughly gives you like the same kind of uniform temperature, in which 50 to 55 kilometers. Well, I guess yeah, around 55 kilometers. that's the temperature at which it would be similar to Earth, in which it has, well, closer to Earth at least, in which it would be a fraction of the pressure. Now, my thinking on this is like if you could graph temperature versus pressure of Venus and do that the same. Oh yeah, and plot the height from the ground, and then turns out people already did this, scientists. So that's what this graph is: temperature up here, pressure down here. This line here is Earth's sea level. So this green dot, it's all right here. It's 15 Celsius. It's sea level, and then as the pressure is you and right here is 11 kilometers. So it's like the pressure decreases as well as the temperature. So we noted that the pressure is in a logarithmic scale here. And then you get to like ozone layer where it gets to almost like I'm pretty sure this is still below freezing, but it heats up here because of the ozone layer and certain atmospheric gases. But amongst the the places where the temperatures where people live, I think even planes fly, it's still like a pretty almost linear line here. And then let's go up to Venus, and their surface temperature and pressure is way fucking higher, but around 50 kilometers, it'll have the same pressure, much hotter temperature, and it's not until around, what would this be, like 55 to a little higher than 55. Because the Wikipedia article I had like just 55, but it's worth noting that this isn't the same. It's not. It's shifted away because they have a different composition of the atmosphere. Because Venus is what it's said it was like 96% carbon dioxide, whereas Earth's atmosphere it's like mostly nitrogen, 70 something percent, and then the next biggest thing is oxygen, and those are both diatomic molecules, which I'll talk. Yeah, I'll get to later why it has a very small effect comparatively. What's the next thing? None. Yeah. All right. I guess we'll talk about that now. Um, I mean, I should just talk about how heat transfer first. It's basically greenhouse gases are just a gas that can absorb and emit infrared radiation. And the biggest one in Earth is water vapor. Second one's carbon dioxide, and you got these others. I think it's like, yeah, it's listed in the order in which, like, how much of it there is. But not all gases are greenhouse gases because some do not absorb and emit infrared radiation. That being nitrogen, oxygen, and argon, which are diatomic or monoatomic. Oh, diatomic containing the same element specifically. Like carbon monoxide would be a greenhouse gas, but thankfully it's a very small. It's not a major part of the atmosphere because it's poisonous. Let's see. Let's go to Earth's atmosphere. What? Sure, nitrogen is like 70 something. Oxygen's 20 something. Yeah. So carbon dioxide, yeah, where Venus is like 96, Earth is 0.04. And that comes up to like, yeah, 400 parts per million currently. Which, that probably doesn't sound like much. It's like, wow, that's, if we have 209 parts per million, or yeah, 209,000 parts per million for oxygen, like, how's that going to affect it? And that's a good question. So, right, this is information based on the ice Yeah, in the Antarctic, there's a lot of ice, and new ice will get like packed on over like long, long periods of time, and there's like the composition of the ice based on the the isotopic ratio of oxygen 18 to 16, I think. I'm remembering right. Let's just what I might say here. Crap. But yeah, one of the ways in which they get the temperature is the ratio of oxygen 18 to 16. Oxygen 18 is like a slightly heavier isotope of just normal oxygen, and during very, very cold, when it's really cold, it crap, is it that its reabsorption from water is greater or lesser in the air? Either way, it's measurable, and that's one of the ways, the most direct way to measure the temperature, because it correlates uh, pretty linearly. And as for temperature or CO2, you can measure that directly, what the CO2 pressure, in a much easier way, where you just take the Antarctic ice and go. There's like any bubbles that are formed, like air pockets. You can just, they're unaffected over time. They're just there and sitting there, and you can measure the amount of CO2. And over long, like the past, yeah, this goes to 400,000 years. They take this, the gray thicker line here is CO2, and the red one is temperature. And it should be noted that this isn't the hottest point in the last 400,000 years. That looks like 330,000 years ago. It was hotter than it is right now. And yeah, this is like the very long distance. To look up the more recent shit, like since thermometers have been made, of which we have even more direct measurements. We have global mean from NASA. Uh, this is 1880s, and the mean temperature at like sea level over time. And it should be noted that there's like a big drop here, and that's likely due to aerosols, chlorofluorocarbons, uh, which was mentioned in the Wikipedia article earlier. What's interesting about those is they actually have a cooling effect, because they absorb a lot more heat than they give off. They also cause acid rain, so it would not be a good idea to just uh, release a shit ton of it. And for land specifically, it's quite similar. But yeah, like the Earth is warming, and it has accelerated the crap. This doesn't map CO2, but let's see. Probably is one here, but Ah, okay, here. Dang it. Basically, the rate of change is it lines up with CO2. Fuck. I thought I had a graph, one of the graphs of this. This isn't the right page. Uh, so, yeah, the current state of Earth is that carbon dioxide is a very small part of the atmosphere, but it's still significant enough to change the temperature. Since the stronger the gases that are uh, prevalent, nitrogen and oxygen, they do not uh, absorb emit infrared radiation. They heat transfer from just like collisions and basic shit. Mainly get it from like the ground or the waters or the air around it. Well, I guess yeah, all three of those. And the greenhouse gases, which are water vapor and carbon dioxide, those are like the biggest ones. Water vapor has been around for as long as water's been around, and the effects of that are also known. And the carbon dioxide, it fluctuates, and in the past, since the Industrial Revolution, it's greatly increased, and that's uh, you can line that up with the temperature of the Earth at sea level, and that's we're like right now we're smack dab in the middle between Mercury and Venus, which has like Mercury having like no atmosphere at all, Venus having one that's extremely like extremely absorbs infrared. And right now we're slowly going towards Venus, but it would take a long time. Greenhouse gas effect, like it would take literally probably like a billion years to get to what Venus is for Earth. But anyway, what are some of the effects that this rising temperature would have? And the most immediate one is for yeah, move this up in OBS. For people that live near the coast. And India here, over a billion people live in India. Pretty populous place. And in Calcutta specifically, Mumbai not so much I don't think, but Calcutta, a lot of people live there. And let's see, this is within 10 meters, so it's like that's a lot of people that would be displaced. Now, the Syrian migrant crisis of 2015 was when uh, I think it was like in that year alone, it was like 1.5 million people were displaced, and they needed to go somewhere. And with Bangladesh here, there's like 150-ish people who live in 150 million people that live in Bangladesh, and at least like 30 million of them live in like these dark red pockets, which is this is persons per square kilometer. Dark red is greater than 1,000, and this is all within like everything that's red is within 10 meters. And as it closer to the river, it gets closer to like zero, and there's about 30 million people, so it's like 15 times the Syrian migrant crisis. So it's like over an order of magnitude more people that are going to need to they're going to be displaced, and they need to go somewhere. And like where the Syrian migrant crisis was called like a crisis, this is going to be a lot worse. There's also a if you look at like low elevation coastal zones, there's a a lot of these, not just for like foreign countries, but also for the United States and Canada. There's, I'm not sure how it's pronounced, but in Vietnam, this place, there's a lot. Netherlands, a lot of the Netherlands is very within 3 meters of sea level, including some of the more densely populated areas like Amsterdam. As for the U.S. specifically, this is New Orleans. The red areas here, the red areas here are 0 to 3 meters, 0 to 3 meters. Orange is 4 to 7. The most densely packed area is also 0 to 7 meters here. So New Orleans will be fucked. A lot of Boston and a lot of New York. Like any city that's ocean near the ocean is likely to have a lot of people that are fucked, including Miami. So the threats of this temperature rising are pretty significant because both the thermal expansion of water, like the higher the temperature of a liquid, the greater the it'll get less dense basically. That the basically the molecules will vibrate more and they'll bounce around more, which will like slightly expands the volume of it. And that's true for water on a global scale, like the oceans, with a small, like the if you're to put like a glass of water, the temperature increase doesn't really mean much, but when you have oceans worth, it does. And this is only that's thermal expansion is one thing. It's also like melting of ice caps. I think it's less of an effect than the thermal expansion over the next 30 years was what was of the articles I was reading was, but anyway, this is, it's not it's not something that you can just pretend isn't happening because there's some very serious consequences. And this is just for like where people are living. The effect on like a survivability of crops and a lot of the near Bangladesh is more significantly than the United States. It was in Bangladesh and India that the effect on crops, just shit to eat, would also be uh, over time. It would be harder to make food, which would United States since crosses an entire continent. Most of the people in the center would be affected like last, but they still would be affected from the warming of the globe, which is measurable and like a direct result or like a linear result of the greenhouse gas effect. It's pretty scary stuff.